questions below, and I'll respond quickly or in the next episode of Louis Yam.
Hey Blake, how are you doing? We got ready to go time, right? It is start of, oh my gosh, Mubot needs to be rebooted. Got some more coffee. We're ready to go. Blake, how are you doing today? Getting started right here. It is Haslam Friday. Woo! Another week. People are saying there might be issues with my Pearson. Hey, I see someone in the chat. Catherine, good to see you here. I got a fun cup today. Doesn't belong to me technically. Vol for lifetime. Gotta go Vol for life right here. VFL. Lindsay, good to see you. Yours is working fine. Yeah, that's why I'm like, see, I'm super worried to move it to Friday. Like if it's a momentary morning issue, then I'm like, okay, everything's good. Where's everyone complaining about my Pearson? I only saw one complaint. I saw one complaint. Mine's working now too. I'm really worried to move it because if we move it to Friday, oof. Yeah. You move it to Friday and then it's like, Friday? Homework on Friday? And then no one does it. And this chapter is a chapter you have to practice. So I'm wondering, how long was it out for? We did have over the summer where it was out for like 3 or 4 days. Over the summer, it like crashed for an extended period of time. And summer is just like, you know, month and a week. So, yeah, that was really bad over the summer when it just completely crashed. So it was out for like 10% of the summer. It's not good. So I have seen issues, and that was the biggest issue I ever saw. And because only 83 people right now have done it. Really good average on the sampling distribution for sample proportion assignment. Does anyone want to do that one right now? What should we do? You name it, we do it. You name it, we do it. Who needs handles? Data analytics? Yeah. We talked about it yesterday, but let's talk about it again today. Like, that really will be helpful right here because it is a little bit of a different one. So let me get that started right here. Stat 201. Data analytics. Is it number 6 or something, or 7? Good question, Lindsay. So for this data analytics, you are writing a report. Number 7. Thank you so much, Catherine. We're making Catherine a mod right here. Catherine, you're now a mod. There's all these new things on YouTube. Still same stuff right there. They've put like a live section. They've changed around the way the channels look and stuff. All these different things. Getting it loaded up. Data analytics number 7. Only one more to go after this. Let's head over to the main screen. Let's do it. Okay, so on data analytics number 7, you are writing a report. I want to show you how your report should look. Not like that. Your report for data analytics number 7 should look something like the following. You are going to be turning in 2 components. Does anyone know in the chat the 2 components? We'll throw out some big points here. Does anyone know the 2 components you're turning in? And probably visually should look something like that. Something like this. So what are the 2 things you're turning in? When you complete your report, probably something about like this is what you'll have. What are the 2 things you're writing? Executive summary and future research. Great job right there. So you're writing the executive summary and the future research. So we're going to learn what those are. And what I mean, like, your report isn't going to look like this, like with boxes. You're going to write a block of text here and a block of text here. You can do some paragraphs. We're going to talk about, no, don't worry, it's great answers. So the executive summary. And the future research. Now, you don't want to write 2, 3, 4 pages. Mubot is awake. You don't want to write, oh, I don't think Mubot, he's not awake. Here, we'll wake him up. He crashes the world behind him. There we go. Thank you, Blake, right there pointing that out. Mubot's waking up right there. Streamlabs chatbot. He's a chatbot. Don't tell me about that. So we have executive summary and future research. So with this, is it better to write half a page or a full page on these? Personally, I would not approve of graders taking off if you write a little bit too much. So is it better to write half a page or a full page? What do you think it's better to do? Now, don't just write a full page to write a full page, probably, hey, Alexander, so good to see you here. Ask any questions to God. Probably better to write a little bit more, right? So to throw on a little bit more, though, a little. I personally think it's better to write a full page, but don't just write random things to write random things. We're going to talk about what to write here in a moment. But, you know, just sometimes people do a little too little. So think about be verbose, be very descriptive, be very, you know, going through the details. So what do you need to put in the executive summary? The first thing of the executive summary is to do what? The very first thing is to do what? Quick question. Why is it ROC curve I see on the internet has... Let me take a look at that. Let me take a look at that here, Alexander. Yeah, let's look at that next. I always hate specificity and sensitivity and specificity. False positive ratio. Oh, I guess because they might be saying that you were... Those are just the no's. Yeah, because if something were to have a high probability, like if you gave something a 98%, those would be things you are saying, like if you say everything's a yes, then going up would be a true positive and then going over would be a false positive, because you're putting something towards the top would be saying it's a like it's a yes when you go over to the right, because that would mean you mislabeled it. It's on the wrong. Does that make sense? So I think I usually think of it as your true positives, because you could look at it that way, but the things towards top, it's all under question one. Yeah, we could look at that next year, Kyle. You got it. When I download, all I see is a ton of question marks and almost none of the report is visible. Yeah, here, Blake, I'll open it up here. Make sure you can get word free from UT. So Blake, I'll open it up right here if you want to screenshot or pause to read it. I'll go through it very slowly so you can read it, or pause and go through it, Blake. What is the first thing we need? So here, we'll open it up in a second. What's the first thing we need to do in our executive summary? You're going to do 3 things in your executive summary. What's the first thing you need to do? What's the first thing? I would do 2 strong sentences right here, right? And your 2 strong sentences like are going to describe like, why is this report done? Who is it for? Like, what are we doing? So this is kind of like a full introduction to the report. Like, talk about who you are, why you're here, and what the report is about. Very high level, like, what are we doing this report for? It's going to make sure the reader knows exactly what this report is and why it exists and who we are. So that's the, like, it's not a full introduction, like, but it's like this report. I don't want to say too much because everyone starts writing exactly what I say, but, you know, make sure it's very clear. So when we look at this, do I still have that one up in the background? I do. So with this right here, that's going to be right here. So you got your 2 sentences right there. Does that make sense? There's your, it might wrap the screen, but I'm representing that as 2 sentences on who are we? Why does this report exist? What are we doing? You know, like, why are we doing this report? So to do this, you need to what? You need to probably go look at what right now? To do this and to write those 2 sentences, you probably need to go and do what? To write those 2 sentences, you probably need to go and do what? You probably need to go and do what? Would be a good thing to do. Go to the report. So at this point, if you want to know what to write, you probably want to start reading about this report. So Blake, here I'm going to do, tell me if I need to go back or go more slowly. So here we are with the report. I'm going to pause as I get to new sections of the screen. So if you want, pause here, Blake, on different sections. Decision tree. I'll put the full decision tree on the screen. Full page output decision tree. There's the leaf report and the tree path. So there's leaf report and tree path. A little bit on the decision tree and its analysis. And a little more decision tree and analysis, a regression model. There we go. Regression, analysis of regression right here. I'll pause right here. Analysis of regression. And last but not least, that's it. There we go. Blake, do you need me to show anything else, like the regression again, the decision tree? Feel free to pause the screen on those to read anything or see where they're at. Let me know anything else you need to see on that. So you want to read the report, understand what they're doing, why they're doing it. If you have time, could you? Yeah, you get it, Javen. So Javon, we got this. Yeah. You got it. Awesome. Let me grab these from people asking, right? Homework 7, B and D, question 1. Okay, and then question A. So people want question 1 a lot. A lot of question 1, 474. BAS 474, question 1A. Oh, don't do like B, C, and D. Okay, there we go. So the first thing you want to do is read the report, understand who they are, what they're doing, why are we here. The next thing you want to do is what? After you've introduced the reader to the whole point of the report, you want to what? After you introduce the reader to the whole point of the report, you want to give what? You want to give what? It says it right there. Give what? Key findings. So to do this, you want to think about taking the report and crunching it down. You don't want to just copy paste sentences, but you want to give numeric values and talk about important things. So I would suggest 3 sentences right here. And you want to give numeric values. Like, think about this. We are going to be drafting, what is his name? David Justice. Yeah, we're going to draft David Justice because he's awesome. Played for the Atlanta Braves. We're going to draft David Justice, even though he's 48 years old. He's probably older than that. We're going to draft David Justice, even though he's 48 years old, because his batting average is currently a 350. Like, we watched him in the league. And so what did I just give? I gave some numeric backing right there. I said his batting average is 350. Well, that's more of an action item. Kind of went towards action item. I could say it was observed in the training that David Justice has a batting average of 350, which is well above the league's batting average of 280. That would be a key finding. Does that make sense? I'm making up some fake data here if you're wondering where is this all coming from. I'm quoting some numbers and telling you that when we went to the training, because I'm pretending that I'm recruiting some baseball people right now. So, like, this report was composed to look at current people to draft for our baseball team, analyzing people who participated in the 2022 preseason game that was done at over the period of blah, 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 blah. That would be the start right there. The next thing is going to be my key findings, which are things like David Justice was observed to have a higher batting average than all other players with a batting average of 350, where the average player had a batting average of 280. That's one key finding. The last thing we give is our action items. So what did I say I was going to do because David Justice is doing so well? What did I say I was going to do because David Justice is doing so well? What was my action item for my fake report? And we should maybe come up with 2 of them right there. So you've got your opening or your kind of introduction, kind of the setting the pace. You got your key findings, and then you've got your action items right there. What did I say I was going to do because David Justice was doing so much better? So I talked about how well David Justice was doing compared to the other players. And then I said what down here as an action item? Like the thing we're going to do. That's what action items are. We are going to do this. This is the plan. Because of the data, we are deciding to do this. So my action item was, we're going to draft him. We're going to put out a contract for him. So the last thing right here is to give the action items, the actions we are going to take because of the key findings. You need to link this to the key findings to say, like, the key findings were this, thus our action items. You can use like a thing, connecting sentence to be like, because of the key findings of blah, 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 we are then making the decisions to blah, 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 blah. Does that make sense what I'm talking about right here? So it all flows. Why would someone read your executive summary? What is the point? Oh, no worries, Lindsay. What is the point of an executive summary? Like, what is the point of this? What is the point of it? Let's see, Sandy. Thank you so much. Try a different browser. Some people are reporting issues. We're going to look into it. Keep me updated, Sandy. Let me know. A few people reported issues. but I don't know if they're intermittent right now or if it's continuing. We're gonna watch it, and I'll give you updates here. Santi, let me know. Try a different browser, see if that works. Try reloading the page. You switch so try a different browser. Try a different browser, and please let me know if it continues. Please let me know if it continues. What is the point of the executive summary? Tried using Safari. I have better luck with Chrome. I use Chrome, and I really haven't had many issues. Didn't work. We'll see. Hopefully, more people aren't reporting issues. Keep me updated on this, though. Sometimes my person has issues. It can happen. It's not good. What is the point of the executive summary? Why does it exist? And then you have to make sure yours does this purpose. The point of the executive summary is so that it's a shortened version of the whole report. This is everything important. Oh, no. This is everything important in your report. Does that make sense? This is everything in your report. Why are we writing? Like, who is the report for? What's the goal? Like, what are we doing here? What are our key findings? And what are our actions we're going to take? Does that make sense? So this executive summary, should someone really need to read your report? I mean, they could if they wanted, but they wouldn't have to. Does that make sense? They don't have to read the report. It's a summary of your whole report. It's the key findings. It's the why are we doing this? It's the what are we going to do from this report? So in the future research, you do not in the future research want to go back through the report. The future research is going to be new ideas. You do not want to go back through the whole report. The future research is more about oh, no worries, Santi. No worries, Santi. The future research is all about new ideas and coming up with things that we didn't consider. Like maybe we could go to a different training facility, or maybe we need to collect more data on David Justice before we make this decision, which is kind of related to what we were doing, but thinking outside the box on what wasn't done. Because you have the summary of the full report, and then between all of this, someone would actually put their report right here. So this is where the report would go. So in between all of this would be your report, which is the full thing that would be. We're not going to put it here when we supply it to the grader, but someone would give their report, and they would give their executive summary first and their future research second. Does that make sense? Like theoretically right here, the future research is new ideas. So that's where you completely come up with things that you just want to examine, want to look at, that are related to what this company does. Don't say we're going to open a bakery, but how does this work right here, Lindsay? Is this making sense? That the future research is new ideas, things that we haven't thought about yet, new ways to go, new trails to blaze, new ideas. So knowing the key components right here. Yeah, awesome. Yeah. I think if people watch this right here, they'll understand what to do. I think sometimes people just say, awesome, Catherine. Yeah. So just think about breaking it into parts. Make sure the reader knows, like, read over the report first, then summarize who is this for, what are we doing, why are we here, then give the key findings, give the numeric backings with the key findings, then give the action items that we are going to take, and then last but not least, give the new ideas. Make sure it's in the future research. And just let me know if you have questions. But the key thing is the executive summary should give numeric backings for key findings. I tell my graders to look at that. Don't be like, this was good and this was bad. Be very specific, but then also give the big key ideas that we're looking at. Yeah, well, that does it. Oh, I hope my Pearson's working. My last question is, when we're submitting the final product, the only thing on our document should be the summary and the research, correct? Or no, just that right there on the page. Your page will look a lot like that, Lindsay. Great question. It'll look a lot like, it'll just have executive summary and it'll just have future research. So your page will just have those two things right there. Your page will just have those two things. Good job right there, Lindsay. Great work. That's all you'll be turning in. Excellent stuff right there. Just those two things. And let's go grab a little 474. 474. Okay, let's take a look. You're welcome. 5. Here we go. So we are going to look at the account data right here. The account data in reg class deals with customers of a bank, whether they have or have not purchased a new CD account offered by the bank. The purchase columns are yes and no. There we go. We got it loaded up. We want AUC to be higher, correct? Yeah. Oh, yes. Oh, yes. Higher AUC means we've correctly ordered the probabilities a higher percent of the time. Higher AUC is better. We want RMSC to be lower. We want accuracy to be higher. We want MAE to be lower because those have error in them. Anything with an E term, we want to be lower, like MAPE, MASE, RMSE. Those all should be lower because they're all error, where things like misclassification we'd also want to be lower because that's the percent time we misclassify. Accuracy and AUC we want to be higher. The tenure and checking balance saving income of columns are all skewed. Logistic regression models tend to be effective when we have things that are more symmetric. So let's replace the values in each column with the log 10 to symmetrize them. However, we need to be careful. The smallest values of tenure are 0 or negative. We cannot take the log of that. Thus, for all the tenure values, add an appropriate value to the column so that its minimum is 1. Okay, so what should we look at right here in the tenure column to find the minimum? We want to go to account tenure, and what should we do to figure out what we need to add? How could we figure out, because we want it to be 1, and the reason why is if you do the log 10 of 1, it's going to be 0. So how could I figure out what the minimum value of tenure is? How could I figure this out? How could I figure this out? Min, yep. So let's go look at the minimum value. Minimum value is that. So what should we add to it? What should we add to the minimum value of tenure? What should we add to the minimum value of tenure? So if that's the minimum value, it says add an appropriate number to the column so that its minimum value is 1. For example, if we had this, we would have to add this to it, and then you would do the following right here. So it's saying that we need to use this, and this is where account, that would be that. But we don't want to do that because what should we add to this? What should we add to this? How would we rule models out? How would we, which one are you talking about, Alexander? So what should we add to this? Let's see, does anyone have ideas on what we should add to this? Because we know the minimum amount is this, but we want it to be 1. It's G when we get to it, and is it G of the first question? I'll put that on here on the list. So I might leave it at this, and then you have to think about saving this and creating these vectors. So you want to store these right here. You want to overwrite. So I might leave this one at this. We don't want to add this, but you want to think about what you have to add to this and to get it to be 1. And it explains right here, but that's what we're doing is we're finding, and then you want to make sure you have that the values that you've changed, because tenure will be changed right here. We're going to overwrite into it. So don't do this, but you need to change what the value is to make sure that when you add to this, the minimum value of tenure is 1. So this is not the answer, but it is the method. So it is the method. That is the method right there to overwrite with a log plus a constant, but you need to know what the constant is based on the value right there. Split the data right here. What class would the naive model predict for everybody? Well, so with tenure, you don't technically have to, but does it say that? Hopefully we'll know. Careful, the smallest value tenure or all but tenure are negative, and we cannot take the R for all but tenure. Yeah, you are correct. So you could do it for tenure. Great job, Alexander, right there. You could theoretically. So it doesn't want you to. Got to read some big points on that. Don't do it on tenure, it's saying. So all the other ones you would need to do it on. Checking balance, it's saying. And so let's look at checking balance. We got some negatives, does it say? Yep. Oh, yeah. So now you need to figure out what to add to this. And it's very specific right here on talking about what you need to do. So it's saying this needs to become 1. The minimum needs to become 1. And then you do have the sanity check right here to make sure you have it correct. But you need to make sure that the minimum value is 1 after you log it. So, or excuse me, you need to make sure it's 1 and then log it. So you would do it inside of here. So don't use this value, use the value. The sanity checks are clutch. Exactly. We love some sanity checks. And so now let's go to question B. People are asking about B, and we're trying to split the data right here. So what do we need to create to split data? What is our method for splitting data? To split data, we need to create a what and a what. To split data, we need to create a what and a what. What do we store into to split data? Splitting data usually means we're creating a this and a this. We split it into two groups, one to train our model and one to test our model. So we store the data into two groups, our what and our what. Train and hold out, exactly. So we like to do the method of making the train.rows, where we then sample from them and check out the notes or the class today. Then we go right here, we store into the train. Then we store into the holdout. So work on completing this right here. We need to do train.rows, sample from 1 through the number of rows, the percent, the 70% wants right there. Then we take and store into the train from the account the rows that are in train rows, and then in the holdout we store into it the not the train rows. So that would be there. But the question becomes, what does the naive model predict? So we are trying to predict the variable of purchase. So what would the naive model predict and why? Now this is not what you should be running right here. Oh my gosh. What does the naive model predict? What does the naive model predict in categorical models? The naive model for categorical models predicts the what? What would the naive model? This is a naive model right here. I'd do it on the train preferably, because I think it says, talks about the train, the holdout. Hey, Evan, good to see you here. So what does the naive model predict? Like, how does it work? Theoretically, the naive model on categorical data predicts the, starts with an M. He's here. The naive model predicts the what? The majority, and so, and we use it on the train. Hey, Allison, good to see you here. The naive model predicts the majority level. So the naive model would predict what right here? And then you probably want to find the probabilities and do it on the train data. So the naive model would predict, like, which class would it predict, first off? The naive model would predict which class right here. Can you read the question? Which question? Yeah, of course. Definitely. The naive model is going to predict Pew Research, you bet. So the naive model is going to predict the majority level. And so the majority level is no. And then we could also talk about the percentages to talk about the probabilities and the percent of time the naive model misclassifies. Dividing by the number of rows in the train data, if we use the train data for this, is going to get it right here. Oh, yeah. Of course, Allison. Thank you. Thank you for the positivity. Oh my gosh, Allison, let's throw you 10. Thank you. Of course. Yeah, just, you know, it's really easy for us to give the exam early. I'm always, if someone has to take the exam late, we'll work with them on that. We want there to be more, like, you know, if someone's sick or accidents happen, we work with people on that. That's where we require a lot more. But if someone needs to take it early because of things, then we're gonna help out with that. Like, I'm all for that. So thank you, Allison, right there. Thank you for the positivity. I really appreciate that. You got this, Blake. It's all about that practice. It's all more practice you get. And you know what? If the exam doesn't go perfect, we still made a bunch of good grades on all the assignments. So the exam is the toughest part. Always remember that the exams are the toughest parts. A's and B's on the exam. So focus on getting great grades on the assignments, reviewing for the test, and then if the test goes all right, that's what we want right there. Need to name this class though, Blake. Keep up the great work. Keep getting those A's on assignment. Keep getting the A's on data analytics. Keep doing the Canvas contents. And then if you study for the exams, they're going to go the best they can go. And that's the best we can do right there. So you got this, Blake. Stay positive. You got this. You can do it. Is chapter 13 on the test? It is. It is on the test. You bet. Chapter 13/14. It's like one chapter on the sampling distributions of the mean and sampling distribution of the proportion. So that's right there. Let's talk about C. We're going to do some, oh no. Oh yeah. Oh no. We got question C right here. We're going to be doing some chapter 13 in just a moment. 122. Love it right there, Alexander. Great job. 3210. Here we go with question C. Although arguments could be made for both metrics, explain why the bank would like to prefer to have models tuned for AUC. So why do we tune on AUC? West investment website? Yeah. Of course. Let me put that in the notes. Nice job right there. Yup. So why would what is the point of AUC? What is the point of area under the ROC curve? What is the point of AUC? Do we do some AUC drawings today? Here we go. Here's an AUC. What is the point of AUC? Yeah, ranking. And then talk about that. So definitely check out the previous classes if you want to hear me go into more detail about how we rank stuff. I talked about reaching out to people to buy homes and why ranking would be important for models. Exactly. We got some legends right here. That's why we call like the top things usually legends. We love it. And we got some new levels from last class. So check out the new levels. As you'll notice right there, we got Ultimate Blake level and a lot of cool levels. We need to see that those people's, because we're going to reach out to people, right? So it's all about probabilities. Make that clear, like very clearly state how AUC is different than accuracy. Because if we're going to be reaching out, we probably want to do that. Define, so it's already defined mostly. I like to let me put the next note in. We're going to be doing some, where's yours? Evan, you want to make one here in a little bit? We'll make one. So let me take a note on this. And if you're wondering about the previous one, if you want to go into more detail, please check out the class or the activity where we go into way more detail on AUC and the importance of it and why a lot of times it makes more sense to do AUC. So that's a big, like, that's a lecture right there talking about AUC versus accuracy. So what are we setting up right here? We're setting up, probably this right here is the clue. What are we setting up right here as I make it look all nice and pretty? What are we setting right here? Eccentric Evan level? Yes. Okay, let's add it in. Was that what you want? Evan, tell me if you want that. Is this Evan from, well, maybe I love it. So what are we setting up right here? What are we setting up right here? What are we creating? And this is the clue right here to what we're creating. Everyone knows each other. I love it. What are we creating right here? What are we creating? Nice. We are creating the cross-validation. Cross-validation is the process by which we validate our model to make sure that we've created it. You know what's really... So, Alexander, does their knowledge of regression come into play from 201? This is senior level class material right here. Does their knowledge of regression come into play with what we're doing right now? Does it play a role in the understanding of what we're doing here? Like, does understanding regression to some degree help with current thing that we're doing? Almost definitely, yes. Because we're doing logistic regression with a categorical Y on probability. So even the probability chapter we did, chapter 12, comes into play right here. Because when you talk about predicting the level of interest, the not level of interest is going to be the complement right there. So everything we're doing from 201 builds into this. 2-class summary means we're building on AUC. Class probs means categorical Y. This is the K-fold cross-validation with 5 folds right here. It walks you through everything. Oh, and then it wants you to make the model. So for this right here, I would highly suggest, I'm going to show part of the answers. Exactly. So important. So important. Here is the model from the activity. So make sure you know the steps. I'm going to review what every one of these things does. This starts with an F. This is our what to build the model. It's the y tilde dot, which means the y with all the x's. That's the what for the model. It's one argument, stands for the what of our model. That is the what. Y tilde dot means your y variable with all the x's. That's our what to build the model. Think of like you're making something. It's your what. It's the formula. That's the formula. Then the data equals is where the data exists inside of, and you need to store inside of your train. The next method equals GLM is the method we're using, standing for generalized linear model. So the whole idea of linear model right here comes into play from 201. But the generalized model means we're using things like logistic, which is just kind of using the general idea of a linear model to predict probabilities with a sigmoidal curve. So GLM is a more general idea of linear models, where linear models are just quantitative. GLM does the logistic curve too. The TR control equals fit control. You probably labeled yours fit control. Mine is called fit control AUC because I set up a different fit control with AUC. Still the same methods. Make sure if you're doing a categorical Y, you use the following. Or if you want to tune on AUC, you do the following. Here with the pre-process, it could be pre or pre-capital P process, but it does a partial match on this, so I just write pre these days. And you do center and scale, and it turns everything into what's. And guess what? It's chapter 5 from 201. Yeah, I will throw 10,000 points if a 201 student says this, or 5,000 points for the 474 student saying it. Everything right here is being turned into what? Hence, it's chapter 5. You're centering it and you're scaling it. You're centering it to a mean of 0 and scaling everything to a standard deviation of 1. That turns all your x's into what's. You might have to answer 474. I know you know it, 474. 201, it turns everything into a mean of 0 and a standard deviation of 1. That turns all your x's into what's. So it's going to standardize them. As Alexander's saying, subtract the mean and divide by the... Alexander, I got 10,000 points for helping out. So Alexander, yeah. So you subtract the mean. So it's observation minus mean over standard deviation. That's the hint. So it's going to turn everything into what's, because you're doing the observation minus the mean over the standard deviation. So what's it going to be? This code right here turns all your x's into what's for us. One letter. You only need one letter. You got this. I'm going to throw another 5,000 points if someone gets it. Because you have to know what the code does, and the code does it for us. Like Alexander's saying, seeing how many standard deviations can go into how far something is away. How many standard deviations is something from the mean? Good to see your meet. Excellent work. So it's going to tell us how many standard deviations the x value is away from its mean. It turns all the x's into what's. One letter is all you need. It standardizes them. Oh, it's Z. Look at Meath right there. We got to throw double points. Meath jumps in. He's like, oh, it's z-scores. So that turns all the x's into z-scores. And the reason we do that is because we don't want some of the x's to have undue influence. Because think about this. If we compare people on salaries have a big difference. But if we compare them on shoe size is smaller differences, right? Is a salary difference of $10 a year big? Like I make $10 more than someone. Is that a big difference? Or they make $10 more than me? We'll go that way. Is that a big difference? Someone makes $10 more than Brian. Is that a big difference? Is that like, whoa? No, that's more like, wow. But what about if someone's shoe size is 10 sizes bigger than Brian's? Someone's shoe size. Oh, it all intersects. Because if someone's shoe size is 10 sizes bigger than mine, that's a big wow. So the reason we turn everything into z-scores is because every x will then be on its own kind of scale to where we could talk about the differences in the x's, but have it on a similar scale. Like an x with a bigger range won't dominate the model because we're using multiple x's. This is actually multiple regression, Meath, right here. This is multiple logistic regression. So this is 320 predicting the probability of someone having diabetes with multiple logistic regression. And all we have to do this is run the following. And we don't have the data in there. Now we run this and we run the model and now we see the results and there's the ROC. I could also look at the accuracy if I tune it to fit on accuracy and just save this over here to fit on accuracy. And now my model accurately predicts someone having diabetes 77% of the time. And that's how quick it can be done. And we can test it on new data to see how it works on new data. But all this right here is just seeing if our model can predict. So check this for 474. Make sure you understand what these codes do. Check out the activity today right here. But there's a huge intersection between all of these. We need to hop down to your question. That was D. Let's go to G. A, B, C, D, E, F, G. So what's the verdict? What models can you eliminate from consideration? So this is really great right here because when we do data mining, we make tons of models. So when you make tons of models, any model within what is virtually identical. So what you want to do, Alexander, and I'll show you a really cool thing. Let's talk about the best way to do this. Here's the number one way to do this. Really? Yeah. Oh, I clicked files. 2 seconds. Standard deviation rule. 1 standard deviation. So you know what we're actually doing again? by using one standard deviation, we're basically doing z-scores again. So here's what I would do, Alexander, is I would take and I would insert a chunk right here. This is Brian's top way to do this question. And I would go here with model name. And I would go here and do the following. Take your model names like GLM, GLMnet. There we go. Then I'd go to the accuracy. Are we fitting on accuracy? Are we fitting on accuracy or AUC? Are we fitting on... There's K nearest neighbor. Which one are we fitting on? Accuracy or AUC? The metric accuracy was none. The result, we're doing ROC. Okay. So I would put the ROC value in here, and we'll just come up with some fake ones. And then I would do ROC standard deviation. And then I would go right here and do max ROC standard deviation. And, well, it gets a little bit complicated because when you compare two models, you use the max of the ones you're comparing. So it'd be a little more complicated with the pairwise comparisons. But we could probably just do it with this table right here. Okay, so now that we have our models, our ROC values, our model names, let's go right here and go to data.frame, model name, ROC value, ROC standard deviation. There's that, but that's not pretty. You ready? Let's call this data frame right here. Let's go to K-table. And no, we need library cable. Not Hable. Cable extra. And K-table. There's a cable. There's cable, data frame. There's no. I thought 2 seconds. I want to make this look real pretty. Cable in R. Cable package in R. Here it is. Oh, it's KBL. Why is it KBL? There we go. Not so pretty. There's that. And then pipe it into cable. There we go. Cable material. There you go, right there. So now, if we take this, we do want the, well, when you compare them, you'd want the max right here. When you compare it, like if you compare, there's only two models to compare right here, you'd compare it via the maximums. These two models are identical. Let's go to knit, and let's see if it knits to HTML. I knit to HTML just to see if things work. Just making sure, let's see right here. As long as I have all my code, so I've got right here, object train not found. There we go, because on line 130, it uses train right here. So let's remove this out because I'm just kind of showing example code. And there's that. Okay, knit. And this is why I like making nice tables on line 130. What's it meta? Oh, this right here. Do that. Last thing. And now, there we go. The system cannot find the specified file. 170, it's mad about 170. All these things that it's mad about. There we go, okay. There we go. So check this out. With this right here, there you go. There's my table, and it actually will change to the size of the page in an HTML document. So, or you could specify, I think in the chunk you can specify the size of the table, but that is my nice, neat table right here, and just learning how to do little things like this can be really valuable. So that's that little table I made right here where I stored it as a data frame and then did KBL. This is the library cable extra. made it into a table, and then I used a kind of template layout on it. So does that make sense there, Alexander? This is a really good way to present your stuff and then to talk over it, to talk about which models are within one standard deviation. You could do the calculations right here to see which one is. So your best one's going to be this one, but comparatively to this model, it's identical. Exactly. And if you want to add another model to this, you would just go right here and do like the k nearest neighbors model. You could pretend the k nearest neighbors model had something like this right here. You could even sort it, but you could do, this, and then you could return it. And now when you create your table right here, it shows the values like that. Make it look super nice. Exactly. And then you can also, I think you can sort the table. Well, we can just go here and go to data frame. You got to do order. So you got to go data frame, order the rows. So you go order on the data frame of the ROC value. And there's that. It's in reverse. So you go decreasing equals true. And there's that. Then you overwrite the data frame. There you go. So now it's ordered it right there. We do have the numbers over there, which I don't love. So we could go right here and go row dot names of data frame is vector 1 through 3. And, just overwrote with that. That's fine. Just making it look as nice and neat as possible and get your stuff so someone can understand it. But does that make sense right here, Alexander? I hope this helps with the question. We're going to do a little 201 after this. But this is kind of the goal, to visually communicate and understand the models we've made, and then to be able to say the k nearest neighbors model is the best, because the k nearest neighbors model has an ROC value of 0.98, accurately gives the yes class a higher probability than the no class 98% of the time. Our uncertainty, so Meath right here, if you're with 320, standard deviations are once again variation in the metric, which is uncertainty, just like standard errors are uncertainty. So we have this amount of uncertainty. So it's like, yeah, I think it's about 98%, but I don't know. I could be off by about. So we could be off by this amount. So we are pretty certain this is the best model. Now, this is not the results of this. It's just a hypothetical example right here. Really good work, really good assignment, and everything you do from 201 to 320 builds into this. So practicing your knowledge and understanding these steps and how to do it, and that's a good bit of the assignment. It's a lot of the assignment right there. Let's do some 201. Who's ready for some 201 in the chat? For 201, can we do Pew Research? You bet. I think that's the next one we got. Who's ready for some 201? It is Tom for some 201. That was Evan's question? Yes. Nice. Thank you, Blake, right there for helping out. I love it how, people knowing each other, giving shouts to each other, saying, hey, that's what we want here. I don't know. It's all about treating each other well. Pearson's issues. Love it. Looks to be a lot of... So some people are saying there's the issue. Oh, we'll find out. We'll keep examining this. Ma Pearson, no, why? So we're definitely hearing about it today. We're gonna keep an update on this. We're keeping an eye on it. Assignment manager. Let's check it out. Chapter 13 quiz. Pew Research. Okay. A lot of similar topics right here, you'll see. 5103. 13. Stat 201, Chapter 13 quiz. Pew Research. Let's check it out. So in this question, you're first asked to understand what p hat means. What is p hat in notation? What is p hat? Hey, good to see you here, McKenna, right there. What is p hat in notation? Like, what does the notation mean? P hat is the what? What is P hat? So what is P hat? What is P hat? What is P hat? So if you estimate of the true probability or true proportion. So it is an estimate and it comes from a sample. So I would say sample proportion. Good job right there, Blake. The sample proportion. So it'll be the sample proportion. So from a sample, we saw this proportion. So it's good to acknowledge the sample size right here. So I see two of them that acknowledge the sample size here and here. This meaning 0.448 is that the researchers that talks about confidence intervals, which we haven't talked about. So let's go down here. This means that P hat is 0.448, meaning that 44.8% of the sample proportion. So here's our sample size. So what is the notation for 1058? 1058 in notation is what letter? So we're just practicing our notation to understand what this is saying. So 1058 is what in notation? That is N, which is sample size. Great job, Blake, right there. So this is the researcher's best estimate of P, and P is the true proportion. So this is exactly what we want to say right here. The meaning of P hat, which is the sample portion, is 44.8% of the sample size, 1058. It reported this. This is the researcher's best estimate of the truth for all teens right there. That is the best estimate of the truth for all of them, which is the true proportion. Now this one talks about standard error. Now standard error is a concept that is just like standard deviation. So I'm bringing up the review 2 notes right here for test 2 review and going to the formula sheet. The standard error is an estimate of the standard deviation. So here's the formula for standard deviation when dealing with proportions. So if we look at the proportion formula right here, we'll see that we're going to use the estimate of it by using the samples. So take a look right here where it says calculate this value right here. Then it asks you, what does this standard error mean? Well, the standard error is the estimate of the standard deviation. It is also relative to a sample size. So let's go to the ones that mention the sample size. How do I know it's relative to a sample size? Well, when you calculate standard error, the formula is standard error equals P hat times Q hat over N square root. Notice how the N is here, so it's relative to a sample size. And what's the only difference between these formulas? And that's correct right there, Blake. What is the only difference between these formulas right here? What do you notice between the standard deviation formula and the standard error formula? Which is what they're trying to point out right here. And if you get the question wrong, I think it even points out how to solve it. It says like standard error is calculated this way. The little hat, right? Meaning sample. Standard error is an estimate. Going like the hats right there. Great job, McKenna and Blake. So the standard error is calculated from the sample, where the standard deviation is from the truth. Both of these are relative to a sample size though. So we need to use the ones that talk about the sample size. So the standard error is the best estimate, not of the margin of error. The standard error is the best estimate of the standard deviation of the sampling distribution. So how do we calculate this? The formula on the screen shows how to do it. So I'm going to show you the values right here. What values do we need? We need P hat and Q hat. So what is P hat, which was mentioned at the start? What is P hat? Put a hat. Yes. Let me grab it right here. So what is P hat? Well, while I put the hat here in the commands, what is P hat? What is P hat? And then be careful though. So a big thing when using it, we need to report it as a decimal because it's a proportion. So it is that percent. It is that percent, but then we report it as a decimal. So then how do we get Q hat? So how would we get Q hat? And great job, McKenna and Blake. We got to throw more points. How do we get Q hat? If P hat is 0.448, how do we get Q hat? Exactly. Yep. 1 minus it. So there's Q hat. It's the complement. Exactly. Practicing how to talk about it. It's the complement. So we're just going to take these values and plug them in and also plug in the value of N, which I think is 1058. Where is it? 1058. It is. And so plug those values in. So we get the values right here of 0.448 times 0.552 divided by 1058 square root, and there's the value. Exactly. P times Q over N square root. But technically, because of the hats, we are doing the standard error right here. To 5 decimals. Be very careful, and if you do get this wrong due to a decimal, let me know. Like if you were to enter in the 8 right here and it told you it's wrong, please let me know. I will give you the points back. That's a bit ridiculous that you have to do it to the 5th decimal. Just be very careful. Even if you were to enter in this, I mean, I don't suggest you enter in that. I would give you the points back because I don't think you're randomly guessing that value. So make sure to enter in the 5 decimals. Do remember, I will give points back. Just let me know if you didn't enter in enough decimals. But always read this little text on the bottom to see what you have to enter in towards. Good question right here, going over some of the concepts of what we do. And so what else do we have? I think we had one more. And do check out yesterday's office hours where we did a ton of these. A lot of people getting hundreds on this. We got the investment website problem. A lot of people getting hundreds on these. A lot of people. I was like, whoa. A lot of people getting hundreds. I'm very impressed. Where's the investment website? What's the investment website one say? Hats and foxes in the chat. Where's the investment website one? How does it start out? Did I not click the full thing? Where is the investment website? 2 seconds here while I try to find it. Investment website. Is it on the homework? Regenerating the quiz right here. Where is the investment website? Quiz wasn't... Yeah, well, I'm glad to hear that. It's a lot of practice. A lot of practice. Same principles throughout, exactly. Like, the chapter's a lot of repeat. It's a lot of, like, knowing the formulas, knowing the conditions. So it doesn't... Like, it talks about the success failure conditions somewhat. Where... I'll look at the homework here in a second. I don't see the investment website one. I recall it, like, I can think of it. It's not there. Let me go look at the homework. I want to find it. Investment website. Here it is. It's on the homework. Okay, investment website. 59, 53, stat tool 1. Stat tool 1. Okay. An investment website can tell what devices are used to access their site. The site managers wonder whether they should enhance the facilities for trading via smartphones so that they can estimate the proportion of users who access the site that way. They draw a sample of 438 investors from their customers. Let's go. Suppose that the true proportion of smartphone users is this. What did they just tell you? What 2 values have you heard right here? This is where you have to practice and you have to know the notation. What 2 values did they just tell you right here? What 2 values did they just tell you? What 2 values did they just tell you? What 2 values did they just tell you? N and P. So what else can we get right here? This is the sample size they took. This is the truth, which they might not know, but that's the true proportion of people that use smartphones to access the site. So what other value can we get if we know P? Correct. Right job. P equals 0.35. Exactly. So what else can we get? We can also get Q. So if we meet all the conditions, we would expect the distribution to look what? If we meet all the conditions, we expect the distribution to look what? Normal. So if we meet all three conditions, randomly select the customers, less than 10% of all customers, and have at least 10 successes, at least 10 failures, the distribution should look normal. So that'll be unimodal and symmetric, which means normal. That's non-symmetric, not normal. Left and right skew are not normal. It should look normal if we meet all the conditions. What would be the mean? Well, think about this. If 35% of people use smartphones to access our site, if we took a sample, don't even worry about the sample size, what percent of your sample would you expect to use smartphones? So if 35% of our sample, or 35% of our population uses smartphones, that's what P is, what percent of your sample would you expect to use smartphones? So that says expected sample proportion. If 35% of people use smartphones, what percent of your sample would you expect to use smartphones? Now, you're not saying this percent of your sample will use smartphones, but you're saying, well, if 35% of people use smartphones, then what would I expect from a sample? If I take a sample from a population where 35% of people use smartphones, in the sample, I'll probably see about what? If 35% of people use smartphones, and I take a sample of them, I probably should see about what percent of people using smartphones. If 35% of people use smartphones, and I take a sample, so I promise, so we know what P is, right? And we're now solving for this. So solve for that value. That's not, we don't multiply those. That's just an idea. That is estimated sample proportion or expected sample proportion. You don't do mu times P hat. Sometimes people say, they're like, wait, what is mu times P hat? It's mu of P hat. It's like, what is the mean of the distribution of the sample proportion? Also better said sometimes as expected sample proportion. So what is this value right here? We know what P is. P is 0.35. So what is mu P hat? So it would be, if it's true that 35% of people use smartphones, and we took a sample, what percent of our sample would we expect to use smartphones? Does anyone have that? What percent of our sample would we expect to use smartphones? Chat's quiet. Well, we know what P is, right? 35% of people use smartphones. So think about this, McKenna. You ready? If 60% of UT was born in Tennessee and you talk to students, what percent of students in your sample would you expect to be born in Tennessee? So let's say it's true that 60% of people at UT were born in Tennessee, which is P. Let's just say that's true. And you go out and talk to students. Don't even worry about how many. What percent of those students you talk to would you expect to be born in Tennessee? So it's true that 60% of the students at Tennessee were born in Tennessee, and you go out and talk to students, what percent of your students would you expect in your sample to be born in Tennessee? So that's what this says right here. This is expected sample proportion. It's just one idea. You might as well just call it X. So if it's true that 60% of students were born in Tennessee, if you took a sample, what percent would you expect to see born in Tennessee? So don't even worry about the math of it. Just think about conceptually. If 60% of students are born in Tennessee, 60%, right? So if 35% of people use smartphones, what percent of your sample would you expect to be using smartphones? So if it's true that 35% of customers use smartphone to do the website, then what percent of customers in our sample would we expect to see? If it's true that 35% use smartphones, what percent would we expect to see in a sample? Like if I go out and sample people, I should probably see close to what? If 35% is the truth, then I should probably see about 35%. So it's like, if that's the truth, we should probably see something close to the truth. And that's the mean. And that's what mu p hat is. So if 35% of people use smartphones, if that's the truth, then we should see about 35%. So we had to find P first because mu p hat is equal to P, which stands for the mean of the sampling distribution is equal to P. So once we knew what P was, we know what mu P hat is, because that's what we expect to see in a sample. Yeah, no worries. It's once you start to get down, you're like, oh, well, if that's what the truth is, I should probably see that in a sample. So then how are we going to calculate the standard deviation? Because the standard deviation means we won't always see 35, 35, 35, 35. To solve for the standard deviation, we have to do P times Q over N square root. P times Q over N square root. And you do get the formula sheet for the test. So there's P, there's Q, and there's N. So a lot of these questions come down to
notation, brother.
You have to know the notation. You have to know how to identify P. Oops, don't put in the wrong value of P. P times Q over N square root. Does that make sense? P times Q over N square root. Notation, brother. So make sure to put them in the right way. You got this. You got this. Yep. And once you get the standard deviation, round to digits. And that's got it. That's a good question. Going over how to write and draw the sampling distribution, because then we could bring that to the David M. Lane applet. Any other last questions? I might go grab some lunch. I didn't eat breakfast this morning. But good work. Any other last questions right here? You got yours right. Nice job, McKenna. And practice the formulas, understand them, know what they're solving for. So make sure you know the notation, how to read a question, identify if it's categorical or quantitative, know the notation, and think about what it's asking. Like, try to envision it. We're going to go out and talk to our customers to see if they use cell phones to access the website. So you're taking a sample of your customers. Now, apparently, we know that 35% of them use cell phones to access the website. So when we take our sample, we would expect to see 35% with a variation of 2.2%. So the variation is the standard deviation, which gives kind of the spread of the data. Well, I'm going to grab some lunch here real quick. And great work, everybody. We did a lot of 474, some 201. Check out the stream right here. And lots of help yesterday's video. We're going to see if my Pearson's doing all right. Until then, bye for now, everyone. Bye, Blake. Bye, McKenna. Bye.